Second lesson will be all about probability. In general, when we say probability, it is when you don't know if the scenario or the given event will happen. It can also be if you are in doubt, if or you are not sure if something or um, some scenario will happen or not. Probability can also be defined as a game of chance, meaning to say you don't know if this might happen or not. And since probability is a game of chance, we are testing that what are the odds in doing a certain action or a certain scenario. Or in simple terms, we can also define probability as the likelihood that something will occur. Before we solve for probabilities of different events, let us first define some terminologies that we will use under probability. The first one is probability experiment or experiment alone. When we say probability experiment or experiment, this is the process of obtaining an outcome wherein you do certain steps, and then after doing these certain steps, in conclusion, we will have the answer. Next is outcome. When we say outcome, these are the result after a single trial or after doing an experiment. Next, sample space. Sample space is the set of all possible outcomes of an experiment. Lastly, event. Event is the subset of the sample space, or we can say that events are another scenario that may happen in a given experiment. Now that we know the terminologies under probability, let us now identify the sample space. We have three ways in identifying sample spaces, and the first one is the listing method. Of course, before we come up with the sample space, we must have an experiment. And let's say that that experiment we are referring to is tossing of a coin. So given this experiment, when we toss a coin, what is the possible outcomes when you toss a coin? If you're thinking that the answer is the head and the tails or heads and tails, then the answer is correct. But since this is a sample space and we are in the listing method, first we have to name or denote that sample space with a capital letter S, since that is a set of all possible outcomes, diba? When we define sample space is the set of all possible outcomes, and in defining set, we must use a capital letter. And just to be unified, let's just use capital letter S in denoting the sample space. And then equal sign, and then you have to enclose in a bracket all the possible outcomes, since it is a set, and this is the proper way of writing a set. Or if you do not want to write the whole term head and tail, you may also write it as S is equal to open bracket H for head, and then comma, and then T for tail, and then close bracket. So these are the possible ways in writing the sample space if you are in the listing method. Let's have another experiment. Let's say we have roll a die. After rolling a die, what do you think are the possible outcomes? In rolling a die, after a single roll, a number might appear. So since it is a die, numbers from 1 to 6 are the possible numbers that might appear in a single roll. So the sample space in rolling a die is 1, 2, 3, 4, 5, and 6, since those are the possible outcomes if you roll a die. And then since this is a sample space and we are in the listing method, you have to denote the sample space as the capital letter S and then equal sign, and then you enclose numbers 1 to 6 in a bracket. What if the given experiment is answering a true or false question? Obviously, since we are answering a true or false question, the only answer or the all the possible outcomes will be true or false, or true and false. So just like in the previous examples, we have to denote the sample space as the capital letter S, equal sign, and then enclose true and false in a bracket. Or if you want, you can just write S is equal to open bracket, T for true, and then comma, F for false, and then close bracket. The next method in identifying the sample space is the tree diagram. Let us use an experiment in explaining how are we going to identify the sample space using a tree diagram. And let's say that that experiment is find the sample space for the gender of the children if a family has 3 children. Use B for boy and G for girl. First, we must identify the possible outcomes for the first child. The possible genders for the first child is either a boy or a girl. After identifying the first child, let's now go to the second child. For the second child, the possible genders are also boy or girl. Going back to the first child, we also have girl as a possible outcome. So we must also reflect another possible set of outcomes as boy and girl for the second child if the first child is a girl. So, parang ang gagawin po natin is, magbibigay po tayo ng option if the first child is a boy, tapos ano yung options niya for the second child, and then, dun din ulit going back to the first child, kung ang first child naman ay girl, bibigyan niyo ulit siya ng another option for the second child. And lastly, for the third child, the possible genders for the third child is also a boy or a girl. And since we already have 4 branches from the first child to the second child, we must also reflect another set of options for the third child. So, parang gaya po nung ginawa natin sa second child, dahil meron na tayong 4 branches mula dun sa second child, ang gagawin nyo is, magbibigay din kayo ng options for that 4 branches na if the first child is boy and the second child is boy, ano kaya yung magiging third child? And the option is a boy and a girl. And then if ang first child mo is a boy and the second child mo is a girl, ano yung pwedeng maging third child? So, kailangan nyo pong lagyan din siya ng branches since kasama na siya sa options or sa possible combinations mo if meron kang 3 anak. So, this is the tree diagram for the experiment asking for the combinations of possible genders if you have 3 children. What we're going to do now is just list down all the possible combinations for those 3 children. So the first one is boy, boy, and boy. The second possible combination is boy, boy, and girl. Third, boy, girl, and boy. Fourth, boy, girl, and girl. Fifth, girl, boy, and boy. Sixth, girl, boy, and girl. Seventh, girl, girl, and boy. Lastly, girl, girl, and girl. Another example in identifying sample space using the tree diagram. So let's say the given experiment is you're asked to find the sample space for a full course meal if you are to choose from first option is the rice meal, one piece chicken or two piece chicken, and then for the drinks we have the Coke or Sprite, and then for the dessert or side dish we have the fries or ice cream. Let us first illustrate the first option for a full course meal is the rice meal, the one-piece chicken and the two-piece chicken. So in a full course meal, we also have the options for the drinks as Coke and Sprite. And since we have two options already for the rice meal, you must also reflect another options for the drinks for the second option for the rice meal, and that is the two-piece chicken. Lastly, the options for the dessert or side dish, and that is the ice cream or fries. Just like what we did previously po, we just have to put another set of options for the dessert and side dish for the other possible set of combinations po. Gutom kayo, no? Ako din nagutom habang ginagawa to eh. So anyway, um, since we already now have the tree diagram for the given experiment, all we have to do is identify the set of possible combinations for the outcomes given this experiment. The first outcome is the set of one-piece chicken, Sprite, and French fries. Second, one-piece chicken, Sprite, and ice cream. Third, one-piece chicken, Coke, and French fries. Fourth, one-piece chicken, Coke, and then ice cream. Fifth, two-piece chicken, Sprite, and French fries. Sixth, two-piece chicken, Sprite, and ice cream. Seventh, two-piece chicken, Coke, and French fries. Lastly, two-piece chicken, Coke, and ice cream. The third method in identifying the sample space is the tabular form. Let me give you an example and showing you how are you going to use this method in identifying the sample space. Let's say the given experiment is you have to find the sample space for rolling two dice. So in this example, we have two dice. So what we're going to do is we will write down the outcome for the first die, all the possible outcomes in the first die in the first row, and the possible outcomes, all the possible outcomes for the second die in the first column. So for the first die, the possible outcomes in rolling the first die is the numbers from 1 to 6. And for the second die, we also have possible outcomes as numbers 1 to 6 also. So what we're going to do is to find or list down all the possible combinations of numbers for the first die and the second die. So para lang kayong nagmo-multiplication table na first row multiplied by the first column, tapos ano yung possible na answer nila. So, ganun yung gagawin natin for the rest of the rows and columns. Parang pagtutugma-tugmain mo lang sila. Para ka lang nagmo-multiplication table. Ganun lang. So, for the first possible outcome is 1 and 1, wherein yung first na 1 natin is the first possible outcome for the first die, and the second one is the first possible outcome for the second die. Tapos, the second possible outcome naman is the combination of 2 and 1, wherein 2 is the second possible outcome for the first die, and then yung 1 natin is the first possible outcome for the second die. So, next, third naman tayo. Third possible outcome or third possible combination for the first die and the second die. Yung 3 and then 1. So, you'll do the same with the rest na 4, 1, 5, 1, 6, and 1. Doing so for the rest of the numbers, the combination of numbers, we now have the answer as this one po. Now that we are done identifying the sample spaces, we can now identify the probabilities of certain events given a certain experiment. But before we identify probabilities, let us first define probabilities numerically speaking. So first, probabilities are in the form of fraction or decimal. So denoting a probability or naming a certain probability, we denote it as the probability of A or P of A. You must also take note that when we're talking about probabilities, probabilities of a certain event should be greater than 0, but it is always less than 1, or in symbols, probability of A is greater than 0 but less than 1. Probabilities can also be equal to 0, and this means that the given event is impossible to happen or will never happen at all. Parang yung pagkagusto lang sa'yo ng crush mo, it will never happen at all. Charot! Probabilities can also be equal to 1, meaning to say, you're really sure or you are really certain that the given event will really happen no matter what. So in conclusion, when you're asked to identify probabilities, the possible answers are only a fraction or 0 or 1. If you got a probability that is a negative number or is greater than 1, then you are certainly wrong po. So again, the probabilities will only be equal to 0 or 1 or any fraction. Here's the guide in getting a probability of a certain event. So, since it is a fraction, we should have a number in the numerator and the denominator. So, what you're going to write in the numerator is the number of possible outcomes of the given event. And then for the denominator, you just have to write the total number of possible outcomes for a given experiment. Sige po, let's try to identify probabilities. Let's say the given experiment is you toss a coin. So the first thing that you will do is to find the sample space for this given experiment. If you can recall, previously we already defined the sample space or identified the sample space for this experiment. And that is S is equal to heads or tails. Meaning to say po, all the possible outcomes in tossing a coin is just a head or a tail. Now that we already have the sample space, we can now identify the probabilities of a given event. And let's say that the given event is the probability of getting a head. So in getting the probability of this event, we must denote it as the probability of A or P, open parenthesis A, close parenthesis is equal to. Then going back to the guide that we have, the number that we will put in the numerator is the number of possible outcomes for this given event. And this given event is a head. So looking back in our sample space, how many heads do we have in the total possible outcomes? We only have 1. That's why the numerator becomes 1. And then all over 2. Ma'am, why is it 2 po? Because going back to the guide again, it is stated that the number that you will write in the denominator should be the total number of possible outcomes for this experiment. So looking back at the sample space, we have two um, two possible outcomes for this experiment. Kaya po, naging 2 yung denominator. So the probability of getting a head is equal to 1/2, or in decimal, it is 0.5. You are not required po to write the equivalent decimal number for every probabilities. It's just that I write it po. Also, you can use any variables for any probabilities. It's just that I like to use the alphabetical letters in order. That's why I use probability of A. But you can use any other letters or any other variables. If you want to use probability of B first or probability of C or the initial of your cross, then you may do so. Let's have another event. So let's say the given event is probability of getting a tail. So just like what we did in the previous event, all you have to do is name this probability, probability of B. You cannot use probability of A again since this is a different event. So in the notation, since it is a different event, we must denote it with a different variable. That's why I use probability of B. And then for you naman, if you want other letters, you may do so as long as it is not the same with the previous probabilities. Kasi po, we are in one experiment po. So, if the given event is not the same, then you should not use the same variables po. So, going back again and getting the probability of getting a tail. So, you go back to the sample space. How many tails do we have? We only have one. So, you just write 1 in the numerator. And then, for the denominator po, you just count the number of total numbers or total possible outcomes in the sample space, and that is 2. That's why the probability of B or the probability of getting a tail is 1/2, or in decimal it is 0.5. So let's have another experiment, or let's have another example. So let's say the given experiment is rolling of a die. So when rolling a die, we have 6 possible outcomes, and that is the numbers from numbers 1 to 6. Next, let's say that you're asked to find the probability of getting an even number. So for this given event, we can now use the probability of A again since this is a different experiment. And then the number that you will write in the numerator for this probability is the number of even numbers in the given sample space. So in the sample space, we have 3 even numbers, and those are 2, 4, and 6. That's why the numerator for this probability is 3 all over the total number of possible outcomes for this given experiment, and that is 6 since we have 6 numbers in the sample space, or 6 outcomes in the sample space. And then, or in conclusion, we have the probability of A as 3 over 6, or the probability of getting an even number is 3 over 6. In simplest form, it is 1/2, and in decimal form, it is 0.5. Again, if I am your instructor or your teacher, you're not required po to write the lowest term if you don't want to, unless it is stated in the directions po. And also for the decimal number, you're not required po to write it in in its decimal form unless it is stated in the direction again. Let's have another event, the probability of getting an odd number. For this one naman, since this is a different event from the previous one, we have to denote it with a different variable. That's why it becomes the probability of B. And then getting the probability of this one, you must identify how many odd numbers do we have in the sample space, and we have 3. Those are 1, 3, and 5. That's why the number in the numerator is 3. And then for the denominator, you have to write that number equivalent to the total number of possible outcomes in the sample space or in the given experiment, and that is 6 since we have 6 numbers in the sample space. So the probability of B, or the probability of getting an odd number, is equal to 3 over 6, or in lowest term, it is 1/2, or in decimal form, it is 0.5.